The mole. We must deal with large numbers of atoms in any real situation, and some unit for conveniently describing a large number of atoms is desirable. The idea of using a unit to describe a particular number or amount of object has been around for a long time. You are already familiar with a dozen, 12 items. The CI unit for amount is the mole. It's defined as the amount of substance that contains as many entities, atoms, molecules, or other particles, as there are atoms in exactly 12 grams of pure carbon 12 atoms. Many experiments have refined the number, and the currently accepted value is 6.022 multiplied by 10 under the power of 23 particles. This number is called Avogadro's number in honor of Amadeo Avogadro. According to its definition, the mole unit refers to a fixed number of items, the identities of which must be specified. Just as we speak of a dozen eggs or a pair of aces, we refer to a mole of atoms or a mole of molecules or a mole of ions, electrons, or other particles. For example, helium exists as discrete helium atoms, so one mole of helium consists of Avogadro number of atoms. Hydrogen commonly exists as diatomic molecules, so one mole of hydrogen is the Avogadro number of hydrogen molecules, but 2 times more of atoms. Every kind of atom, molecule, or ion has a defined characteristic mass. It follows that one mole of a given pure substance also has a defined mass regardless of the source of the sample. This idea is of central importance in many calculations throughout the study of chemistry and the related sciences. The mass of 1 mole of atoms of a pure element in grams is numerically equal to the atomic mass of that element in atomic mass units. This is also called the molecular mass of the element. Its units are grams per mole. For instance, if you obtain a pure sample of the metallic element titanium, whose atomic mass is approximately 48, and measure out 48 grams of it, you will have approximately 1 mole or Avogadro number atoms. The amount of, in this picture, you can see the 1 mole of aluminium, mercury, and other elements. It's examples. The amount of substance in moles is calculated as the sample mass divided by the molar mass of the substance. This one. So let's try to use this formula and calculate the amount of moles of atoms of iron if we know the mass of this iron and the molar mass of this iron. Amount of substance can be calculated by using mass and molar mass. Mass divided by molar mass is approximately 2.45 moles. Many chemical reactions are more conveniently carried out with the reactants mixed in solution rather than as pure substances. A solution is a homogeneous mixture at a molecular level of 2 or more substances. simple solutions usually consist of one substance, the solute, dissolved in another substance, the solvent. For example, solutions of hydrochloric acid can be prepared by dissolving hydrogen chloride, HCl, a gas at room temperature and atmospheric pressure, in water. Solutions of sodium hydroxide are prepared by dissolving solid sodium hydroxide in water. The solutions used in the laboratory are usually liquids, and the solvent is often water. These are called aqueous solutions. They often use solutions to supply the reactants for chemical reactions. Solutions allow intimate mixing of the reactant substances at the molecular level, much more than would be possible in solid form. We sometimes adjust the concentrations of solutions to speed up or slow down the rate of reaction. Concentrations of solutions are expressed in terms of either the amount of solute present in a given mass or volume of solution, or the amount of solute dissolved in a given mass or volume of solvent. So we have different type of concentrations. Concentrations of solutions may be expressed in terms of percent by mass. Percent by mass of solute, which gives the mass of solute per 100 mass units of solution. You can use this formula to calculate percent by mass. And mass of solution is mass of solute plus mass of solvent, so you can also use this formula. Okay, let's try to use these formulas, and let's calculate the mass of nickel sulfate contained in 200 grams of 6% solution of nickel sulfate. Okay, by using this formula, we can easily calculate the mass of nickel sulfate. 6 multiplied by 200 grams of solution, 6%, and divided by 100%, it's 12 grams of nickel sulfate. Molarity, or molar concentration, is a common unit for expressing the concentrations of solutions. Molarity is defined as a number of moles of solute per 1 liter of solution. You can use this formula, or if you remember, we can calculate amount of substance by using mass and molar mass, and so this formula is more useful because you can weight a mass of solute, and if you know the molar mass of solute, you can calculate molarity of solution. Okay, let's also try to use these formulas, and let's calculate the molarity of solution that contain 3.65 grams of hydrogen chloride in 2 liters of solution. If you use mass of hydrogen chloride and molar mass of hydrogen chloride and volume of solution, we can calculate the molarity of the solution as exactly 0.05 mole per liter. In this picture, you can see how can you prepare a solution. For example, potassium permanganate solution. For example, we can weight some amount of potassium permanganate, 0.395 grams, and dissolve it in a volumetric flask, not in full flask, but in some amount of water, and then add water to the mark that indicate the volume of this volumetric flask, and it will be your solution. If you weighted this amount of substance and dissolve it in this flask, I think it's easy to calculate the molarity of this solution. You can try it by yourself. The solutions of acids and bases that are sold commercially are too concentrated for most laboratory use. We often dilute these solutions before we use them. We must know the molar concentration of a stock solution before it's diluted. This can be calculated from the specific gravity or density and the percentage data given up the label of the bottle. We can calculate the molarity of solution by using this density and special gravity and percentage by mass of concentrated solution by using this formula. How can we obtain these formulas? We already know that molarity can be obtained from mass of solute, molar mass of solute, and volume. But we also know that mass of solution divided by molar mass of solution is the density of solution. And mass of solute can be calculated by using percentage by mass and mass of solution. So by using all these units, we can calculate molarity from percentage by mass and density. Density in gram per liter or gram per milliliter by using this formula. Let's try to use these formulas, and let's calculate the molarity of molarity of commercial sulfuric acid. If you know its percentage by mass and special gravity. Special gravity is numerically equal to density, so you can use this specific gravity like density. I think it's very easy exercise. Please try to do it. By using this formula, it's easy to calculate the molarity of sulfuric acid by using percentage by mass, density, and molar mass of sulfuric acid. So molarity of this commercial sulfuric acid is approximately 18 mol per liter. Recall that the definition of molarity is the number of moles of solute divided by the volume of solution in liters, and multiplying both sides of equation by the volume, we can obtain that the result of multiplying of concentration and volume, for example, before dilution, is equal the result of multiplication of molarity and volume after dilution. This expression can be used to calculate any one of 4 quantities, then the other 3 are known. We frequently need a certain volume of dilute solution of a given molarity for use in laboratory, and we know the concentration of the initial solution available. Then we can calculate the amount of initial solution that must be used to make the dilute solution. This is example how can you dilute some solutions. For example, with this 100 milliliters of potassium bichromate with molarity 0.1 mol per liter, and then you transfer this volume to the another volumetric flask, for example, for 1 liter, and then raise it 3 times this small flask by a small amount of distilled water, and then transfer it also to this flask, and then add distilled water to the mark that indicates exactly 1 liter of the solution. You can obtain diluted solution of potassium bichromate. And by using this formula, you can calculate molarity of this new solution. Is easy. This initial volume is the initial molarity, is the final volume in milliliters, 1000 milliliters, and this will be final molarity. Okay, let's try to use this formula, and let's calculate how many milliliters of commercial sulfuric acid is required to prepare 1 liter of this solution of sulfuric acid, 0.9 mol per liter. And let's use this relationship. And I think it's easy to obtain that the volume of initial solution will be approximately 50 milliliters.